first of all, when you see this chapter 1, the particulate nature of matter. Okay, so we have three physical states of matter, which are solid, liquid, and gas. Okay, solid, liquid, and gas. Okay, so we have to understand solid, liquid, and gas based on kinetic particle theory. Okay, so of course, what is kinetic particle theory? We will see that in details. For now, you just need to remember solid, the particles are like this. That means they are like orderly arranged. For liquid, the particles are like kind of close to each other, but they have small gap. Okay, some are still stick to each other. Compared to gas, you can see they are not stick to each other. They are separated with more space in between. They are moving quite fast. Okay, so compared to others. So you see the arrow here that says heat increases. That means when you heat up solid, it melts and become liquid, and then it boils and become gas. So when a solid is heated, particle vibrate faster about a fixed point, causing particles to move further apart, and so solid expands. Okay, so from here you try to understand one thing. Solid, the movement or the motion of solid particles is vibration. So when particle gain sufficient energy to overcome strong forces of attraction, they move out of their fixed position and can slide over each other in a continuous random motion. Solid has melted. So from here, you can see a few important points. The first point is when you heat up the solid, it melts. Okay, it melts. So the solid melts. When the solid melts, basically they take the energy to overcome the forces of attraction. Okay, so that's the first thing. The second thing is you can see the type of motion of liquid where they can slide over. Okay, they can slide over, they can move in random motion. Compared to solid just now, they are just vibrating. Okay, now next point, particle and liquid have energy to move around, but are still close to each other and do not have enough energy to overcome the forces that hold them close to each other. So they are still having forces that hold them close to each other. Okay, so if more heat supplied, particles move faster until they have enough energy to overcome the forces of attraction. Particles escape the liquid surface and move around in continuous rapid motion. The liquid has boiled. So from here you can see two important points. The first point is when you continue to heat the liquid until it boils, so during boiling they are using the heat energy to overcome the forces of attraction. This is the first point. And the second point is you see what kind of motion they have. They are having continuous rapid motion. Okay? Continuous rapid motion, that means they move in all directions randomly. So in the vapor, the particle move in rapid random motion. This is the type of motion. This movement is due to collisions of vapor particle with air particles. Okay, so let's move on. Okay, in this table you can see states of matter. We have solid. Solid has strong forces of attraction between particles, and then you have fixed patterns, or we call it lattice. Okay, so when you see lattice, that means it's the repetitions of a certain arrangement, so we call it lattice. Atoms vibrate but can't change position, so they just vibrate on the same position. Okay, they will remain at that position. They cannot go to another place. Fixed volume and shape. So solid has fixed volume and shape. So let's see liquid. Weaker attractive forces than solid. they use up some heat energy to overcome the forces of attraction during melting process. So that's why you have a weaker forces of attraction, weaker attractive forces. Okay, so no fixed pattern. That means the particles is arranged in a pattern that is not fixed, and liquid take up shape of their container. Now, because it has no fixed pattern, right? So they just follow the container. If the container is round, is spherical, then the liquid is spherical. If the container is cuboid, then the liquid is in cuboid shape. Particles slide past each other. Okay, so this is the motion, sliding, and then just now solid is vibrating. This one is sliding. Okay, gas, almost no intermolecular forces. That means during boiling, heat energy is used to overcome all the forces of attraction. So that's why at the end, when they become gas, no intermolecular forces. Particles far apart and move quickly, collide with each other and bounce in all directions. Okay, then you can see the process. Solid to liquid is melting, liquid to gas is vaporization, okay, gas to liquid condensation, liquid to solid is freezing, solid to gas is sublimation. So sublimation, you need to remember two examples. So the important example, the substance that goes through sublimation is iodine and dry ice. Dry ice is carbon dioxide. Okay, so then we have the reverse sublimation, which is gas to solid. Okay, then we see here melting, heat energy gain, endothermic. So endothermic means the absorb energy, basically. The particle absorb energy from the surrounding. Boiling, gain energy, endothermic. Condensation, heat energy loss, exothermic. Freezing, loss also, exothermic. Sublimation, gain, endothermic. Reverse sublimation, lost, exothermic. So if you look at this diagram, basically when you go to the right, it is heat energy gain and endothermic. When the arrow point to the left, it is energy loss, heat energy loss, and exothermic. So you use the diagram to take the theory straight away. Okay, now let's move on. Okay, now you look at the second page of this chapter. So you can see the graph here where solid melt. When it's melting, the temperature remains the same. Okay, so of course we have to know the reasons. Okay, there is a concept in this way. Heat energy is supplied to the substance. Okay, heat energy is supplied, but the substance use the energy in two ways, basically. The first way is they use it to increase the kinetic energy. The second way is they use it to overcome the forces of attraction. So you can see two of these scenario in this way. If there is an increase in kinetic energy, the temperature will increase. If they use the heat energy to overcome the forces of attraction, so the temperature will be the same. Okay, so if you have these two concepts, right, everything should be easier. So let's say I call this A and I call this B. Okay, so now let's look at the graph again. So let's say you heat up the ice, then the temperature increase. So what you should expect is A. You heat up the ice particles increase in kinetic energy. Okay, now the ice melts. So you should refer to B because there is no change in temperature. So same temperature, that means what happened to the heat energy? It is used to overcome the forces of attraction. Okay, so overcome the forces of attraction until finish melting. Now it become liquid. So the liquid is heated. And what happened? Because you see temperature increase, right? So you should use air again. When temperature is increasing, kinetic energy increase. Okay, now it start to boil. Temperature is the same. Same temperature, use B. Overcome the forces of attractions. Okay, so the liquid use the heat energy to overcome the forces of attraction and become gas. Now finish boiling. Now it become gas. So temperature increase. So we have to use air again. Temperature increase. That means the gas particle is increasing in kinetic energy, or they are moving faster and faster. Okay. Let's see here. So this is the graph again. So solid ice increase in temperature, and then this is where it melts, and then it become liquid, and this is where it boils, and then it continue to go up in temperature. Okay, now let's see the next one. Diffusion. Diffusion is the spreading of one substance through another from a region of high concentration to a region of low concentration due to the continuous random motion of particle. Okay. Evidence for diffusions. Okay. Now you can see in liquid potassium manganate 7 in a beaker of water. Okay. So what happened is you put 1 drop of potassium manganate 7 at the bottom of the water. Maybe you can use a dropper or a pipette to put the potassium manganate 7, and then you just wait. Then the potassium manganate 7 will just move up, and you can see diffusion happens. Okay, so in gases, you use 2 gas jar. So one of the gas jar has bromine vapor, another one is just the normal air. Then you remove the cardboard in between the 2 gas jar, then you can see the bromine diffuse upwards. Okay, so that's diffusion. So we use something colorful so that we can see that. So factors that affect the rate of diffusions. So the first factor, temperature.
Sir, can you give me a minute? I have a phone call to make.
Okay,
Mom
sure.
is actually calling me up. Sorry.
Okay, sure. Okay, so just now we are talking about factors that affect the rates of diffusion. The first factor is temperature. So if the temperature is higher, the rate of diffusion is higher. So the second factors that affect the rate of diffusion is the density of the gas. If the gas has lower density basically it means light. Okay, it is light. The gas is light. Then the rate of diffusion is higher. So one of the example that we can take here is, let's say we compare between 2 gases, let's say nitrogen and carbon dioxide. So nitrogen is lighter. Okay, so of course if you learn the mass of the relative molecular mass of nitrogens, relative molecular mass, we will learn this later, so which is 28. Relative molecular mass for carbon dioxide is 44. Okay, so nitrogen is lighter, and because of that it has a higher rate of diffusion. Carbon dioxide is heavier, so it has a lower rate of diffusion. So the mass or the density affect the rate of diffusion. Okay, now let's see the pictures here. Okay, so what we can see is we have NH3 on a cotton wool over here, HCl on the cotton wool on the right. Okay, so let's see the relative molecular mass of ammonia first. So ammonia, basically this is 14 plus 3. 14 plus 3, the relative molecular mass is 17. So how to count this? We will learn it very soon. Okay. Relative molecular mass for HCl is basically 35.5 plus 1, 36.5. So from here we know that HCl is heavier. So if it is heavier, of course you should expect it to move slower. So it is moving slower. It is moving slowly. Okay, and ammonia is moving quickly because it's lighter. The rates of diffusions to the air is fast. And because of that, you should expect this to move fast, this to move slow, and they will meet up somewhere here, not in the middle because ammonia is fast. Okay, so they will meet up somewhere to the right hand side. Okay, to the right hand side because ammonia is moving quickly. Yeah, okay, and then they form ammonium chloride. Okay, so of course what happened is ammonia react with hydrochloric acid, so they form ammonium chloride. Okay, ammonium chloride is the white cloud in the middle. Okay, now let's see this part. The following diagram shows the 3 states of matter and how they can interchange. Okay, so name the changes A to E. A to E. Yeah? Okay, so we start from A. So what do you think for A?
A is freezing.
Freezing, okay. How about B?
B is sublimation.
B is solid to liquid.
Sorry. B is
Yeah.
melting.
Melting, yes, correct. Melting. Okay, how about C?
C is
Liquid to gas. Yeah.
C is condensation.
Condensation. Yeah. Oh, sorry. Gas to liquid. Condensation. Correct. Condensation. How about D?
D is boiling.
Boiling. Correct. Okay. How about E?
E is sublimation.
Yeah. Sublimation. Okay. Now let's see part B. They say name a substance which will undergo change E. Do you still remember any example? Sublimation.
Naphthalene.
Naphthalene. Okay, yeah, it's fine. Naphthalene. Okay. Naphthalene. Okay. The best answer you put is iodine or dry ice. Yeah. So naphthalene, of course, kind of true also because you see you put the naphthalene ball in your wardrobe to avoid cockroach. So after a while, then you can't see already. So that seems to be sublimation. Okay, but it is possible to heat up naphthalene and change it to liquid also. So you're taking risks if you say naphthalene, Okay. Now let's see part C. Name a substance which will undergo changes from solid to liquid to gas between 0 degrees Celsius and 100 degrees Celsius. So do you think of anything? Any substance that undergo
sure, but sodium hydroxide, is it okay?
Sodium hydroxide.
Or sodium
Sodium hydroxide.
right.
NaOH. Okay, sodium hydroxide, is a solid at room temperature. It's a solid. Yeah, so it doesn't become gas at 100 degrees Celsius. Okay, so
Yeah.
the easiest example will be like water. Water. At 0 degrees Celsius it's solid.
Yeah.
And then at 100 degrees Celsius the water change to steam. Okay, so that will be safe to use.
So what about alcohols like ethanol and
Yeah, that will be fine. Okay, if you say ethanol, that is fine. Ethanol. So ethanol, we need to know the at 0 degrees Celsius whether it becomes solid or not. Okay, so to know about this, yeah,
not
okay,
I don't think so.
yeah, at 0 degrees Celsius maybe it is still liquid. Okay, let's see.
Yeah.
Melting point of ethanol. So from here you see at 0 degrees Celsius it is still liquid. Okay, so because of that okay, we can't take ethanol already. Okay, so let me rub away because it's just liquid and gas in this range of temperature. Now let's look at D. Describe what happens to the particles of the solid during change E. What happened to the particles?
Particles they gain heat energy
Yeah.
and
Okay. Particles gain energy. Yeah.
to overcome the forces of attraction.
Okay. To overcome the forces of attraction. Okay. Okay. Yeah. Then it become gas. Yeah, it become gas.
So, sir, for like questions like D, we don't have to put increase in kinetic energy because it's not so correct, right?
No, we can't say increase in kinetic energy because there is no change in temperature during sublimation. Okay, so sublimation, same like melting and boiling, it happens at the same temperature. So what happens to the energy is to overcome the forces of attraction. Okay, so particle gains energy to overcome the forces of attractions, and then they move in random motion. Okay, so it depends on how many marks are given. So if they give more marks, then you give more point. Okay, now let's see E. Which of the changes A to E will involve an input of heat energy? So which one? Input of heat energy.
B,
B, correct? And
C,
C. C is gas to liquid. Gas to liquid is condensation. Condensation will be exothermic. So it should be D, yes. B and D.
D, yeah.
B and D you need to heat up. Okay, sublimation also actually, sublimation, E also. Okay, now part 2, output of heat energy.
Output of heat energy will be freezing with
Freezing,
A
okay.
and melting.
Melting.
No, and C.
C, okay, condensation. Okay, now let's see this part. Below is a heating curve for a pure substance. It shows how the temperature rises over time. When the substance is heated until it melts, then boils. What is the melting point of the substance? Okay, so what do you think?
The melting point is 17 degrees
17.
Celsius.
Okay, 17 degrees Celsius. Now B. What happens to the temperature while the substance changes state? What happened to the temperature?
Temperature rises.
Changes state. For example, like melting and boiling. So temperature should remain.
Temperature remains constant.
Yeah, remain constant. Okay, so temperature remains constant. Okay, now let's look at C. The graph shows that the substance takes longer to boil than to melt. Suggest a reason for this. Okay, so you can see here the line is shorter and the line is longer for this. So what is the reason?
It's because that's when the bonds are breaking.
Yeah. You have to break more bonds when liquid change to gas. Okay, so more forces of attraction, or you can also say more chemical bonds are broken. In boiling. Okay, now let's see part D. How can you tell that the substance is not water? Okay, so how we know it's not water?
Because it boils above. Its boiling point is above 115 degrees.
Yeah. So water has a boiling point of 100, not 115. So from here we can reject water. Okay, so part F, sketch a rough heating curve for pure water. Okay, so for part F, of course you can just sketch a similar graph, something like the given graph, but you just need to change the temperature. Okay, so something like this, from here. Okay, so where this is 0, this is temperature in degrees Celsius, and this is 100. Okay, and then this is time. Then you label solid, liquid, gas. Okay, so that is the graph. So we have settled this. Okay, now let's look at the past year questions. Okay, So for multiple choice questions, okay, let's say question 1. In which changes do the particles move further apart? So move further apart, that means the particles are further from each other. Okay, so what do you think? Which one?
I think Y.
Okay. And
Y and Z.
okay, Y and Z, correct. Okay, so basically what happened here is Y is boiling, Z is melting. So boiling and melting, so the particle are moving further apart. Okay, so let's see question 2. Diagram X, Y, and Z represent the three states of matter. Which change occurs during boiling? Okay, so what do you think? Boiling.
During boiling, I think Y
Okay, 2.
and also Z.
Z. Okay, Y to Z. Okay, so which is B? Y to
Yeah.
Z. Okay, now questions 3. Which change of states take place during evaporation? So what do you think? Evaporation.
I think B.
B. Liquid to
Yeah.
gas. Okay, correct. Question 4. In which process do particles move closer together but remain in motion? Okay.
I think D.
D.
Yeah.
Freezing. Okay.
D. Donkey.
Donkey. Okay. So donkey is where liquid change to solid. Okay. So they are getting closer, which is true. Remain in motion is not so true already. Yeah, not so true. Of course, you may feel like, oh, they are still vibrating, right? But that is a better answer. Okay. A will be the better answer. You see, A is gas to liquid. Gas to liquid. Okay. Gas to liquid, gas, rapid random motion. This is still motion. Okay. So this is better, a better choice compared to this. Maybe you feel like this is still motion, vibrating is also motion. Vibrating is just a small little motion, so which is not so good compared to A. This is a better choice. So sometimes we have to choose the better choice out of the two correct answer. Okay, so the better choice is A. Okay, so from here you can see certain techniques. Two possible answer, which is better? A is better. Question 5. The changes that occurs when a substance changes states are shown below. Which process W, X, Y, or Z is occurring in the following 4 situations? Okay, so let us discuss one by one. Butter melts on a warm day. So which alphabet?
W.
W. Okay.
W.
Yes. Number 2. Water condenses on a cold surface.
Z.
Condense is vapor to, gas to liquid. Gas to liquid.
So
Gas.
Y.
Yeah, it's Y. Okay, now number 3. The volume of liquid ethanol in an open beaker reduces.
X.
X. Okay, so After all this is evaporation, so it's true. And number 4, ice forms inside a freezer.
It's Z.
Z. Okay. So from here, we choose the correct answer. So that should be boy. Okay. So now let's see number 6. The diagram shows a sugar lump in a cup of tea. Which two processes must happen to spread the sugar evenly in the tea? Okay, so what do you think?
First is, I think, dissolving.
Okay,
No, first I think it's diffusion, then dissolving. For the second.
diffusion then dissolving. Okay, so you think it is A. Okay, so in fact it is B. It dissolves first. It dissolves first and then it diffuses. Okay, so it dissolves first. What is the difference? Dissolve means it become aqueous. It become aqueous. The sugar is not solid anymore. It become aqueous. It dissolve in water. Then only it move around. Okay, move around to make the tea sweet. Okay. A. If you choose A, that means the sugar solid move around first. Move around, then it dissolve afterwards. Okay, so it is actually B. It become liquid first, become aqueous first, then it move around. Okay, so this is B. Okay, now let us see some paper 4 questions, which means the structure questions. Okay, so this question 1, kinetic theory explains the properties of metal in terms of the arrangement and movement of particles. Okay, how's the solid arranged, how they move, vibration, okay, and then how's the liquid arranged, and how the motion, and how's the gas arranged, and how's the motion. It's basically these two important aspects, the arrangement and motion. Okay, then let's move on. Nitrogen is a gas at room temperature. Nitrogen molecules and two are spread far apart and move in a random manner at high speed. Draw the electronic structure of a nitrogen molecule. Show only the outer electron shell. Okay, so of course this is not under chapter 1, okay, but we just go through also we just do it okay, although it's not chapter 1 we just do it. Okay, so first you have to know a nitrogen molecule is N2. Is N2 and we also need to know, you can also check periodic table when necessary. Nitrogen is having 7 electrons. So where you have to put 2 electrons in the inner shell and 5 electrons at the outer shell. So they expect us to show only the outer electron shells. Okay, so we just draw a circle of 2 of the nitrogen atoms, and then we put the electrons. Okay, so 1, 2, 3, triple bond. Okay, triple bond, then we should expect 3, 4, 5, something like this. Okay, 5 dots for the nitrogen, and then after that for another nitrogen atom, so we use 5 cross, let's say 1, 2, 3, 4, 5. Okay, so we do it like this. Okay, now let's see how you get marks. How you get 2 marks. This question is 2 marks. So the first marks is given when you have 6 electrons between two nitrogen atoms. Okay, so which means this part you get 1 mark. Triple bond, in other words. Okay. Then the second point, you get the second point when the examiner see one lone pair on each nitrogen atom. So which means this one, okay, this one. So for these two, when they see the lone pair, then they give you the second mark. Okay. Other than that, it's optional, so you can put something in between to show the nucleus. But it doesn't have extra marks for that. Okay. Now let's see part 2. Compare the movement and arrangement of the molecule in solid nitrogen to those in nitrogen gas. Okay, so they give 3 marks. So when they give 3 marks, right, so they should expect 3 pair of comparison. 3 pair of comparison. So for example, let's say for this, right, we can put it in you can write in sentence if you want, or else you just put a table, it's fine also. Okay, so let's say I write in words. Okay, I start with solid. Solid has regular arrangement of particles, or you can also call it lattice. While gas has irregular arrangement of particles. Okay, so 1 mark only for this point, the first pair of comparison. Okay, now what else? You can compare the distance of the particles. So solid has particles that are close to each other, while gas has particles that are far apart. Okay, then second marks. Now the third marks, solid vibrate. Solid okay, has particles that vibrate, while gas has particles that move in random motion. Okay, now I just underline the keyword, or I just circle the keyword in green color. Okay, so the keyword regular versus irregular, close versus far apart, vibrate versus move in random motion. So these are the 3 pairs of keywords that give us 3 marks. Okay, so now let's see part B. A sealed container contains nitrogen gas. The pressure of the gas is due to the molecule of the gas hitting the wall of the container. Use the kinetic theory to explain why the pressure inside the container increases when the temperature is increased. So of course you should talk about the kinetic energy. Okay, so collision with the wall of the container. Okay, so to talk about from the things from this aspect. Okay, so 2 marks are given here. Okay, so first, when temperature is increased, right, so you must talk about this point. Particles have more kinetic energy. Okay, so should be kind of reasonable to talk about this. And second, you have to say if it has more kinetic energy, then what is the consequence? So they collide harder. To the wall of the container. So from these 2 points, then you get 2 marks. Okay, so let's move on. We look at the next part. Okay, so we look at the next page then. The following apparatus can be used to measure the rate of diffusion of a gas. So you see the pictures here, you can see they say constant pressure applied. Okay, so they are pressing the piston of the gas syringe. So the gas is pressed. We have a metal foil in front. Gas escape through a small hole in foil. So you can see there is a small hole there. So the gas will come out. The following results were obtained. Nitrogen, temperature is blank. Rates of diffusion 1, 0.63, and then 1.05. Okay, so there are 2 same gases here, but the rate of diffusion is different. This is higher rate, this is lower rate. And this chlorine, chlorine, right? Logically, you have to know that Cl2, N2, and N2. You use periodic table to find out their relative molecular mass. You should understand that nitrogen is 14 plus 14. The relative molecular mass is 28. Relative molecular mass for chlorine, 35.5 times 2 is 71. So relative molecular mass for nitrogen, again, this is 28. And after that, it is reasonably true, this is heavier. If it's heavier, the rate of diffusion should be lower. So if these 2 have the same mass but have different rates of diffusion, where this one has the higher rate of diffusion, you should expect the temperature to be higher. So we get some idea why they leave us blank and what we can predict. Okay, we look at C first. Explain why nitrogen gas diffuses faster than chlorine gas. Different mass now, different mass.
Density.
Yeah, different density. Okay, so 2 marks are given. Okay, so first point, you can say nitrogen has a smaller MR. Okay, MR is the acceptable short form to represent relative molecular mass.
MR is relative molecular mass.
Yes, correct. Relative molecular mass. Okay, then second point, you can say nitrogen molecules move faster than chlorine molecules. Okay, so you set up the reason, then you set up the consequence. Okay, so normally it is like this. Okay, now we see part 2. Explain why the nitrogen gas diffuses faster at the higher temperature. Okay, so 1 mark question. So of course at higher temperature it is moving faster, or it has more kinetic energy. Okay, so we can write it down in this way. Nitrogen molecules have more kinetic energy. Okay, and then you will get the marks.